We can turn to the analysis of the measured data, and we start with the angle of oscillation during oscillation. And for that, we're using essentially the data coming from the iPhone gyroscope. So first of all, we have a look at the expected behavior of theta if the smartphone is freely oscillating. And we should have such a evolution, such a change of the theta angle, and if that is experimentally observed, then it means that we have essentially defined a maximum angle, frequency of oscillation, and a time of relaxation. These are the quantity that we should be able to measure if that behavior is observed, and this is where we're heading now. So what we observed is the theta versus time measured 100 times a second for a period of time that is about 100 seconds, is more than a minute, and an angle moving from 0.3 to 0.05 roughly, which means an angle moving from 15 degrees down to 3 degrees. When the angle is 50 degrees, it's questionable if the approximation of small angle is still valid. But if we do a calculation immediately, we see that the sine of 0.3 is equal to 0.29. So we believe that the small angle approximation is still okay, really. Just looking at the behavior, we immediately observe, at least for the long time, that we have oscillation omega with a frequency omega that is pretty well defined, and that also we observe the relaxation that we expect to describe with the time tau, using theta to t equal t to 0 sine omega t exponential minus t over tau. Let's have a look if that makes sense and if we can define omega and tau quantitatively. So now on this curve we have both the blue curve that we had before, that are the experimental data, and now we have a red curve that's the best fit with omega equal 3.19 plus minus 0.01 radian per second, and tau essentially equal to 35 seconds. If we change omega by 0.01, then we see that the fit is clearly worse. So we have a period of time that's about 1.97 seconds at best, and that gives a length of the pendulum that's about 0.96, 0.97 meter, which makes sense with when you look at the cable of the iPhone we have used. So it's rather amazing to see how well that can be described.